Hello students. So we finished with the topic vectors and now we are going to start with the third chapter, motion in a straight line. I know we had begun this chapter before our summer vacations, summer break, and we discussed one or two topics also like distance and displacement and speed and velocity and the types, and then our vacation started. But then I realized that you need to study vectors because that concept will also be required over here. So that's why I started with vectors. So now resuming with our third chapter, let's do a quick revision of whatever we studied. So we studied we studied about distance and displacement. What is distance? The total length of the actual path between initial and final positions is known as the distance. Okay. If you go from one point to another, then whatever path you take, like for example, this is point A and this is point B, okay? If you go from A to B like this, then the length of this path, this curved path, the total length of this actual path will be the distance, and displacement will be the length of the shortest path between initial and the final position. So what is the shortest path between initial and final position? Always the shortest path is a straight line joining the 2 points. Which are the 2 points? The initial point A, the final point B. So whatever may be the path taken by the object, you just join the initial and the final point by a straight line and calculate that length. The length of that shortest path will give you the displacement. Okay. Both distance and displacements are denoted by S. Distance is a scalar quantity, displacement is a vector quantity. So we denote displacement with the vector sign. Okay. Then we also discussed about speed and velocity. What is speed? So speed is given by distance upon time. Okay, so we can write speed is change in distance upon change in time. Delta is by delta t. And similarly, velocity is given by displacement upon time. That is again delta is by delta t. What is the difference? That velocity is a vector quantity. So velocity is displacement upon time. Speed is distance upon time. We also say that speed is the magnitude of velocity. Right? We also call speed to be the magnitude of velocity, because velocity will have magnitude plus direction, or we can say velocity will be speed plus direction. So what is speed? The magnitude of the velocity. How to find speed? If you have different various speeds of a body, then the total speed can be found out by bx square plus vy square plus vz square, like that, or v1 square, v2 square, v3 square. If it has speeds in different various coordinates x, y, z, then you can find the magnitude like this. Okay. Then we discussed the types of speeds and velocity. We have various types: average speed, then average velocity, instantaneous speed, instantaneous velocity. Let's quickly discuss about average velocity. Average velocity will be given by total displacement upon total time. Okay, so average will be for a particular time interval. Like if a body is traveling with various velocities, this velocity is going on changing in a particular length of travel, then the average velocity will be the total displacement covered by the body upon total time taken. Okay, and if for a particular slot it is asked, for example, what is the average velocity between the third second and the first second, for example. So displacement in the third second minus displacement in the first second upon t3 minus t1. So this will be the average velocity. Okay. What is instantaneous velocity? Instantaneous velocity is velocity at a particular instant. Okay. Similarly, if the velocity is going on changing continuously, then if you want to find out the velocity of the body at a particular time, at a particular instant, for that we find instantaneous velocity. How do we find that? When we go on reducing the time interval delta t, and we take delta t to be a very, very small quantity, then delta t will be changed to dt. and delta S will change to ds. So ds by dt will be the instantaneous velocity. Okay. So instantaneous velocity can be found out by using the formula ds by dt. What is the formula for velocity? Delta S by delta t. When you reduce this time to a very small amount, then delta t will be small change in time. Very small change in time will be dt. Okay, so ds. Now this ds by dt is of the form of dy by dx. Remember, we studied dy by dx is what slope of y versus x graph. This we studied when we studied differentiation, right? And if you have not viewed those videos on differentiation, please go back and watch them first. So velocity is instantaneous velocity is a graph of s versus t. If dy by dx is slope of y versus x graph, then ds by dt will be what? Slope of s versus t graph. Okay, so if you have an s versus t graph, distance, displacement versus time graph, for example, it's a straight line graph. That means displacement versus time is having a constant slope. Constant slope means if you find the slope of the graph at any point, tan theta, then that slope will give you the slope will be equals to change in distance. This is for example S2, this point is S2, this point is S1. So S2 minus S1 upon, for this S2 what is the time? Let us take as T2, and for this the time is T1. So S2 upon S1 upon T2 minus T1. So that is nothing but delta S by delta T. What is delta S by delta T? Velocity. So the slope of S versus T graph gives you velocity, right? And if you remember studying this in class 9, when we studied motion in a straight line, I gave you a formula that if you have an ST graph, BT graph, AT graph. If from an ST graph you go down, find the slope of the graph, you get velocity. Velocity and graph slope gives you acceleration. If you go up and find area under the graph, from an AT graph you get velocity, and area under the velocity time graph will give you distance covered. Okay, so you can apply that here also. But now we study conceptually. Then you just had to remember the formula. So I gave you a short trick. Here we will study conceptually. So the slope of delta S by delta T or a slope of S versus T graph gives you velocity. Now if you, for example, the velocity is changing continuously. Here the slope is constant, that means velocity is constant. But if, for example, the velocity of a body is changing continuously, let us say the velocity is changing continuously, for example, S is equals to T square. Okay, this is the relation between distance and displacement and time given. So can we draw a graph? First we will draw a table for S versus T. When T is equals to 0, 0 square is 0, so S is 0. When T is equals to 1, then 1 square S is 1. When T is equals to 2, then 2 square S is 4. When T is equals to 3, then 3 square S is 9. If you want to plot this on a graph, then taking S on the y-axis and time on the x-axis, 0, 1, 0, 2, 4, 6, 8, 10 like this, and 0, 1, 2, 3, 4, 5, 6 like that. So when time is 0, distance is 0, we got 1 point. When time is 1, distance is 1, so this will be 1. Okay, this is the other point. When time is 2, distance is 4. Okay, so for time is equals to 2, distance is 4. This is the other point. When time is 3, distance covered is 9. Okay, So this is the other point. So what kind of graph we are getting? See, if we join all the points, you're getting a curved graph, right? Curved graph. For a curved graph, if you want to find the slope of this curved graph, then how to find the slope of this curved graph? See, at any point, for example here, we want to find the slope of this graph over here, then what do? We draw a tangent at this point. Then theta. This is the slope of this graph at this point. What about the slope of this graph at this point? At this point, draw a tangent. Now, this is theta. Okay. What about this point? Now, this point is like this. Now, this is theta. Can you see theta is going on increasing continuously for this curved graph? What is theta? If theta is increasing, then tan theta is increasing. Tan theta is slope of a graph. What is, if tan theta is going on increasing, that means slope is going on increasing. Okay. Slope is increasing. What is slope? Slope of ST graph is nothing but velocity. So velocity is slope of ST graph. And if this is increasing, that means velocity is continuously increasing. So velocity is changing, variable velocity we are having, and if we want to find the velocity at a particular instant, let us say if we want to find velocity at a particular instant, then we use the formula ds by dt. So that is ddt of, what is s? S is equals to t square. Substituting s is equals to t square, velocity will be ddt of t square. What is differentiation of t square? That is 2t. Okay. Now you got the formula for velocity. If you have a time distance relationship given, you can find velocity by finding ds by dt. This is the formula which will be applicable every time. If displacement is given, you can find velocity using ds by dt. Okay. Now for example, at t is equals to 1 second. Now t is equals to 1 second is an instant. If I ask you what is the velocity of this particular body at t is equals to 1 second, not the average. At t is equals to 1 second, so put t is equals to 1 over here. Velocity is 2 into 1, that is 2 meter per second. What is the velocity at t is equals to 4 seconds? Now again 4 seconds is an instant, so velocity will be 2 into 4 at t is equals to 4, so that will be 8 meter per second. So you are getting the instantaneous velocity by using ds by dt. What if I ask you to find average velocity? Find average velocity between t is equals to 4 or between t is equals to 1 to t is equals to 4 seconds. Okay. So here when time is 1 and time is 16 will be over here. Time is 1 and time is 4. In between this time, time is 1 and time is 4. Between this time, what is the average velocity of the body during this time interval? So we know V average is equals to delta S by delta T. That will be equals to, between 4 to 3 seconds will be S4 minus S1 upon T4 minus T1. So we can find S4, we have the value of S is equals to T square. So S4 will be equals to 4 square, that is 16. Okay, and S1 will be equals to 1 square, that will be 1. Okay, so S4 minus S1 will be 16 minus 1 upon 4 minus 1, that will be 15 upon 3, that will be equals to 5 meter per second. So like this we can find average velocity of a body using the formula delta S by delta T. And if you have to find the instantaneous velocity, which formula we use? ds by dt. Similarly, if velocity is given and you are required to find the distance, the displacement of the body, vice versa. See, when displacement is given, velocity can be found out by finding the slope of the graph or using the formula, okay, differentiation. What if velocity is given and displacement is asked? So for that, using this formula, we can write ds is equals to v dt. Right? ds is equals to v dt. Now integrating both sides, integration ds is integration of v dt. Integration of ds from like 4 to 1 will be the displacement, okay, s, and integration of v dt will give you the displacement. Okay, so if you have to find velocity from displacement, you use integration. If you have to find displacement from velocity, you use differentiation. Right? So this is about average velocity and instantaneous velocity. To get the concept clear, let's take 2 or 3 nice numericals. So s is equals to t cube minus 6t square. Find velocity at t is equals to 1 second and t is equals to 3 seconds. Also find the time when the body is at rest. So there are 2 parts. First, let's find the velocity at t is equals to 1 and t is equals to 3. So these are what? Instantaneous velocities at particular instance. So if s is equals to t cube minus 6t square, we want to find instantaneous velocity. Instantaneous velocity is given by ds by dt. That is ddt of s, that is t cube minus 6t square. Okay. Now taking the differentiation of t cube will be 3t square minus differentiation of 6t square is minus 6 into differentiation of t square will be 2t. Okay. So 6 into 2t, that is 3t square minus 12t. Okay, so we got the formula for velocity, instantaneous velocity. Now velocity at t is equals to 1 second. Instantaneous velocity will be 3 into 1 square minus 12 into 1. That is 3 minus 12, that is minus 9 meter per second. Okay, so what is minus 9 meter per second showing you? Why is it minus 9? Minus 9 is not less than 0. It is showing that the force because of which this velocity in the body, that is opposite to the direction of the velocity. Okay, or you can say acceleration is opposite to the direction of force. Similarly, velocity at t is equals to 3 seconds. Right? So that will be equal to 3 into 3 square, that is 9 minus 12 into 3. So that is 27 minus 36. Okay, 27 minus 36. So what is the instantaneous velocity at t is equals to 3 seconds? That is again minus 9 meter per second. Okay, so the instantaneous velocity is not changing, it can change. Okay, that's just a coincidence. Then the next part is find the time when the body is at rest. When will the body be at rest? Of course, when its velocity is 0. So we have the formula for velocity, 3t square minus 12t will be 0. Then the velocity is at, then the body is at rest, velocity is 0. So we can write 3t square is equals to 12t. Okay, then t is equals to plus minus, no, not plus minus, t is equals to 4 second, 3t square, no, not like this. 3t square minus 20 is equals to 0. So t, 3t, t minus 4 is equals to 0. So 3t is equals to 0 or t minus 4 is equals to 0. So 3t equals to 0, that means t is equals to 0 or t is equals to 4. So either the body is at rest at t is equals to 0 seconds or at t is equals to 4 seconds. Okay, so this is how we can find the velocity, instantaneous velocity, the average velocity when the body is at rest. Let's take one more question. So s is equals to 3t square plus 4t plus 9. Find the velocity at t equals to 2 seconds and average velocity between 1 to 4 seconds. So you are going to find both the velocities. See, velocity, so ds by dt, v is equals to ds by dt, that is ddt of 3t square plus 4t plus 9. So that will be equals to, differentiation of 3t square will be, 2 will come, so 3 2s are 6t plus 4. Differentiation of 9 will be 0 with respect to t, that's a constant. So 6t plus 4 is the velocity. Now velocity at t is equals to 2 seconds will be equals to 6 into 2 plus 4. 6 2s are 12 plus 4, that is equals to 16 meter per second. So velocity at 2 seconds is 16 meter per second, that is the instantaneous velocity. Then we need to find the average velocity between 1 to 4 seconds. So average velocity between 1 to 4 seconds is delta s by delta t, will be equals to s at 4 second minus s at 1 second upon t4 minus t1, right? So S4 we'll find quickly. S at 4 will be equals to 3 into 4 square plus 4 into 4 plus 9. So that will be equals to 4 4s are 16 and 16 3s are 48 plus 4 4s are 16 plus 9, that is equals to 48, 64, 73, that is equals to 73 meters, S4. Then S1 will be equals to 3 into 1 square plus 4 into 1 plus 9, that is equals to 3 plus 4 plus 9, that is 13 plus 3, 16 meter. Okay, S1 equals to 16 meter. So average velocity between 4 and 3 seconds is 73 S4 minus S1, that is 16 upon T4 is 4 minus 1, between 4 and 1 seconds. So that will be equals to 73 minus 16 is 73, 63 and 57 upon 3. Okay, so that will be 90 meter per second. So average velocity between 4th and 1 second is 90 meter per second, right? So you'll find such numericals in your books, NCERT or SL Aurora. So keep looking for the questions on average and instantaneous velocity, distance and displacement, and then in the next class we'll start with acceleration. Okay, keep studying.